Integrated development environment plays a very important role in keeping our code structure and efficient. Yes, there are many IDEs for various programming languages out there, but in this video, we will discuss a few of the efficient open source IDEs available with their features and run through of the interface with small example codes. These IDEs can be used in the machine learning domain as well. Naming a few, we start with Jupyter Notebook, Google Colab Spyder R Studio working with Python Programming Language. So if you feel the need to dig deeper and know more about it, stay right where you are as we are going to bring you all the information that you need right on your screen.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions and I will respond to your comments.
Now, very quickly, let me walk you through the agenda for today's course. In today's course, we are going to discuss about Jupyter Notebook, Google Colab, Spyder, and R Studio.
Now, without further ado, the first item on the agenda, let's get started. What is the meaning of a Jupyter Notebook, right? To answer this question, we have to ask another question. What is a notebook, right? To get to a Jupyter Notebook, first of all, you need to understand the context in which we're talking about notebooks, right? A notebook is basically, a book which consists of a lot of information in the real life as well, right? Now, I have multiple notebooks where, each book is maybe for a subject like how it was in the schools and colleges. But the notebook that we're talking about here in general, let me tell you about it. Okay, so when we're talking about a notebook, what is it in our context? Well, to be very honest with you, it is nothing but a very simple document that consists of a variety of information either of the same domain, of a different domain, or something which has a structure associated with it, right? Now, in our case, what we do is in a notebook, we divide a huge piece of Python code into many tiny pieces of code snippets called cells. And in fact, there we go on to not only just program, we can write the code, debug it, modify it, delete something. So you have it's like a playground for all of you all developers where you have access to a fantastic user interface. You type your Python code and you get started with it in a very simple fashion, right? Now, this is where the most advantageous a notebook has been, is that getting started with Python when Python started getting really popular, maybe in 2014 or 2015, it was very difficult then, at least in my opinion, for beginners to install Python, get started with it, set the environment variable, do this, do that, have configurations and all of that, right? With the case of a notebook, you're going to be saving yourself all of this effort and still have Python to work along, right? So it's always fun to have one single document that will not only give you the ability to just, run the code as and when you require, but also display output, display error messages, warnings, whatever it is. So it's complete, it's a complete document which consists of everything you need, maybe apart from the actual files, right? Now, in the demo that we are going to do, ladies and gentlemen, we are going to take a look at a data set as well. I'm going to be showing you how to import a data set into your Python Jupyter Notebook as well. Right now, that's an important concept all of you all should know about. We're going to discuss that. So you should have had some clarity at this moment in time about what a Jupyter Notebook is, right? So to talk about Jupyter, you can see that the spelling is different, right? It's not the same spelling that you would associate with the planet Jupiter we have in our solar system. Now, Project Jupyter is actually a fantastic open source program, which again, multiple developers came about, right? If you've heard of this concept called IPython, well, Jupyter Notebook was actually born, out of IPython. So it was basically the inception of Project Jupyter in 2014 from all the developers who used to work on IPython. Of course, in that arena and domain as well, right? So it is a very nice tool in a way where it offers you fantastic user interface, a graphical user interface wherein you can have your codes in tiny pieces and snippets, and you can have such levels of modularity, right, which was pretty much impossible before Jupyter, in my opinion. Now, whenever you're taking a look at why Jupyter Notebook is even so popular, or whenever you're taking a look at coding contests, Kaggle, or wherever it is that people are trying to solve problems using programming, there you will always see that, hey, here's a notebook with my solution, right? It's a very common thing to do. You can give everything, you can have headings, you can have explanation to your code, you can have comments, inputs, outputs, data, everything that you require. As I told you, it's called as a notebook because it has all of these things, right? So right from 2014, I remember starting to use Jupyter Notebooks, right? So somewhere around 2015. And then, of course, Google Colab came into the picture. So you do have some people using Colab and some people using Jupyter Notebook as well. Google Colab is nothing but a Jupyter Notebook. It works very similarly, has a very similar user interface, but it is hosted completely on the Google Cloud platform. So there is zero processing that is required from my end apart from an internet connection to use, in fact, the world's most powerful graphical processing units. In fact, the world's most powerful servers themselves, right? Of course, since it's a free tool, it's an open source tool. It's not like the entire thing is provided to you at Google Colab. But hey, Google is still providing a facility for you to do it for free, right? The advantage with the Jupyter Notebook here is that you can take your code anywhere with you. It's going to be in a single file. It's a completely structured piece of file that you can carry, you can share with friends and all that, right? So it's this kind of interactiveness, right? It's basically a computational notebook which gives you fantastic options to interact with it, write code and execute. I think this is the reason why Jupyter became super popular. Right now, this was when users and developers were getting started with the tool. But if you really have to talk about how Project Jupyter became the number one thing, take a look at these two concepts. It's called quick prototyping and exploratory data analysis, or EDA. Let's talk about quick prototyping for a second. Quick prototyping is one of these situations where you have an idea and you want to say, hey, I have this idea, I have this problem, I know the solution. I want to quickly type in a piece of dirty code which may or may not work, or it might be pseudocode or anything like that. And I just want to make sure that I go from thought to product really quick, right? At least the first version of the product. It's also called as a prototype, right? If you're a person who's in this kind of a workflow where you just want your idea to go from its inception all the way to a product really quick, then having a Jupyter Notebook is going to help you immensely, right? That's again the number one selling point for Jupyter Notebooks. The second thing is, when you're taking a look at exploratory data analysis, usually when you're doing complex analysis, right? Again, as we've been doing on multiple videos here, on the Great Learnings YouTube channel, you can definitely understand one thing about data analysis is that it will ensure that even though things don't get complex syntactically, once you start looking at 100 lines of code all bunched up together, it can be a little confusing. Again, here is where the modularity aspect of Jupyter Notebook, just wins across the board, right? Now, I am just naming the concept and saying that it wins because if you are not accustomed to using Jupyter Notebooks and that first time you use it, it's like being a kid in a candy store, right? That's how happy Jupyter Notebooks really make me, because again, I am not really a fan of command line interfaces where you have to sit and type in there, or I mostly do not use a lot of IDEs as well. So if you're on the same train, you definitely will love this, right? So one question I usually get asked all the time is, hey, so okay, if you're talking about a Jupyter Notebook, now this is from the people who do not know what a Jupyter Notebook is. They'll be like, okay, so what does this user interface look like where you can write and put in your Python code and execute it really well, right? Well, the interface is on your screen right now. We are going to check all of this out practically. In fact, this is just a screenshot of the demo that we are going to be taking a look at, right? So for the people who are very much interested, we're going to be taking a look at a complex demo. I'm going to be simplifying it to a super simple level where you will not only understand the demo, you will not only understand a little bit about Python and data science, but the main aim of that demo will ensure to make sure that you guys understand how you work with Jupyter Notebook and how best you can use it for your projects going ahead as well, right? But then taking a look at an interface like this and seeing the Python code there, in my opinion, is definitely better to a lot of the IDEs that I've used, and definitely a lot better than the Python command line interface, at least for my preference when I'm in the zone and I'm writing a lot of code, right? Fantastic. So I hope we are clear with the user interface. We are going to walk through all of these things practically. But then before we get to the point, we really have to talk about a lot of stuff and understand it theoretically as well, right? So here's the next thing that you really need to know about Jupyter Notebooks. Jupyter Notebook has its popularity so strong in today's world that it has become the de facto standard whenever people are looking forward to performing research, using the Python programming language, or of course using the other programming languages that are supported by Jupyter Notebook as well, right? This is a super important thing for all of you all to know at this moment of time. Why? Because we're not talking about personal applications. We're not talking about commercial applications. Remember, we're talking about research, the root of everything else, right? I mean, it is a super important part of either creating a product or even thinking about creating a product, right? Research. If this entire process can lean against Jupyter Notebook and Jupyter Notebook can support it completely, there is no tool that is more wonderful than that, is what I believe, right? That is what, again, it's not just my words that I'm saying all of these. When you take a look at researchers, when you take a look at scholars, or when you take a look at hardcore programmers, when you ask them, hey, what's that one tool that's really helped you a lot, maybe with Python or R programming language, the first tool they usually prefer putting out there is straight up saying Jupyter Notebook, right? So this is thousands of developers out there, and I definitely concur with their opinion because as I told you, if it's this good, it definitely requires a spot in the research domain, because there, if you get to work on efficiency, and if you're working on research and you're simplifying your manual tasks, or your own thought process has more room for research, it's always a better thing, right? So that's an important point I wanted all of you all to know as learners. The next thing which I always get asked about whenever I'm giving a seminar about anything related to data science, whenever I'm talking about data science, the first question I always get asked usually is, hey, do you use a Jupyter Notebook as well? Right? Now, this is from the people who know what a Jupyter Notebook is. Now, for all of you all who might not know, you have to understand that data science is a huge domain, right? It's literally an ocean's worth of a domain. Now, if there is a tool that can help simplify a lot of things for you when you're working with this domain, don't you think that's an advantage? That's the reason, again, why Jupyter Notebook came into the picture. They said, hey, our tool is going to simplify a lot of things for the programmers who are working with data science. And it has become such an integral part of data science today, be it online, whenever you're learning using content, or whenever you're seeing someone actually build an application. I think it's rare people are using IDEs to get there. Most of these solutions, or most of these applications can actually build by just using the command line interface, or in fact even using a Jupyter Notebook, right? So for data science, this tool is helping very, very much. And if you guys are data science enthusiasts watching this video right now, and if you have used a Jupyter Notebook, you know exactly what it is that I'm talking about, right? Now, for the people who do not know what I'm talking about, do not worry. At the end of this particular tutorial, I will make sure that all of you all get to take away a good amount of knowledge, a solid understanding of Jupyter Notebooks, right? Look at it. We're just a short way into the tutorial, and we've understood many things about Jupyter Notebook, right? Well, there is more. This is a question, ladies and gentlemen, that you see on your screen right now, to which you already should have an answer to, because I actually gave out an answer a little bit before, right? So is Jupyter Notebook a paid tool? Well, the answer to it is absolutely no. Is Jupyter Notebook a paid tool? No. The entirety of how Project Jupyter was even born is by having open source as its main pillar, right? So when anything is open source, it means that there's open contributions from people around the world to develop that particular product. Similarly here as well, Project Jupyter and Jupyter Notebook is, at least Jupyter Notebook is a free tool to use, wherein you can go on to work on it, type in your Python code, execute it fine. So you really do not have to pay anyone, in fact, to use Python as well, and of course to use the Jupyter Notebook as well, right? So it's completely free, be it for personal use or be it for commercial use as well, right? Now we are gonna talk about a little bit of key features of Jupyter Notebook that you guys definitely should think about, and you should always keep in your mind whenever you are thinking about either finding your favorite IDE, or in fact, if you're confused between multiple flavors of Jupyter notebooks that are out there, right? We're going to be talking about the vanilla, the original Jupyter notebook out there. Well, first of all, let's talk about how Jupyter Notebook even supports this plethora of languages that we have in today's world, right? See, we have so many programming languages in today's world. So for a tool to support most of these or all of these is really impossible. But then when you take a look at Jupyter Notebooks, right? So this notebook, in fact, the entire project Jupyter supports over 40 programming languages, everything from Python, R programming language, and Scala, right? That's the logo you see on your screen in case you guys haven't worked with big data tools, right? So the third logo you see on your screen is Scala. As I just mentioned, it is super popular for big data. Right, let's take a look at the next feature. Now, the next feature talks about having an interactive user interface, right? It has happened to me, in a decade's worth of programming, where you actually will understand your output better if you have a very clutter-free and a clean-looking user interface to work with. First of all, right? That is exactly what Jupyter Notebooks offer to you. It is not just that you can type in your Python code, have some inputs, give it some data, you have your output, and you're done, right? You're talking about making your own process of writing the code very efficient in a way where maybe you have a lot of time to actually think about solving the problem, or in fact also thinking about the logic actively rather than breaking your head about Python's complex syntax, or maybe you looking at the syntax and getting confused, or if everything looks cluttered to you if you're working with the command line interface, or maybe even an IDE, right? Of course, I'm not saying IDEs are bad. IDEs are absolutely fantastic, but then in this particular situation, I believe that the Jupyter Notebooks have a slight advantage, at least in terms of how well it is presented to you, how simple it is, how modular it is, right? So this is an important feature that all of you all, ladies and gentlemen, should know about. Now, once we understand about its interactive user interface, of course, I'm going to guide you guys practically by showing you all the things, all the options and all of that. But it's not only all these things that we're talking about is what makes Jupyter Notebook super popular. You can write all your code in one place. You can understand the output better. And of course, all the other 100 advantages we just spoke about right now. But the most important thing is that you can really share it easily, right? You might have seen the file extension .pynb, right? .pynb basically stands for Python Notebook, right? It's a notebook file wherein you can have text elements, explanations, code snippets, images, videos, audio. I think you can have literally anything you want there if it helps you solve the problem at hand in any of these domains, right? Most popularly, it's used a lot in data science and competitive programming, right? Fantastic. Now, you have to understand that you can have just this one file, which is maybe like what a small program is 100 kilobytes, 200 kilobytes. It depends on the program itself. So you can, directly upload it to the cloud, share it in an email, put it up on your GitHub in case if it's your program that you have worked on, right? So you can do a lot of different things with Jupyter Notebook. The most important abilities, whenever you're usually using Jupyter to solve a problem, it is a team effort, right? It's not like you're solo doing everything. That is when you might have to write a piece of code, share it with a couple of friends, share it with your testers, share it with another entirely different team or a shareholder, right? That is where, this is just a click of a mouse button, hit save, attach the file, send it in a mail, and even they can open it in their Jupyter Notebooks, work on it, change on it, debug something, send it back to you, and you're good. That is a convenience which is very rare in the world of programming, right? I mean, IDEs do this, but Jupyter Notebooks do it better in an easier fashion, let's just say. Nice. The next point that we really have to talk about, the important key feature here, ladies and gentlemen, is basically talking about big data integration. See, I believe that the entire world is a big data problem today, right? I mean, we are generating so much data, right? Terabytes and terabytes worth of data got generated by the second I did that, right? By the time you heard the sound, there are multiple thousands of terabytes worth of data that was either being shuffling around the world, that's been moving, or that's being created right now. That's a fun fact, right? So knowing that we are living in a world where we are being surrounded and to a point where you're almost suffocated by the amount of data that we have, having the ability to actually leverage all of these things using tools from our domains such as big data is something super fantastic, right? Here in the case of Jupyter Notebooks as well, this is exactly what we do in the case of using it with programming languages like Python, using it with programming languages like R, or even Scala, as we discussed, right? So it's a very important thing. Now, after you understand all of these things about the key features, in fact, even an introduction, knowing what a notebook is, you guys even saw the user interface for a second there, I'm sure you will have this question that says, hey, okay, so who uses Jupyter Notebook, right? So if you were to understand about who else uses Jupyter Notebooks, well, you're in for a treat. Let me tell you this. A Jupyter Notebook is used by millions and millions of people across the globe, right? In today's world, there's somewhere around 700 programming languages, of course, in total today. And some of these programming languages have not just one integrated development environment, as in IDE, but multiple IDEs, right? Think about Python itself, ladies and gentlemen. Python can be, you can write Python code on PyCharm, you can write it in Google Colab, you can write it in Jupyter Notebook, you can write it in multiple different places with multiple different user interfaces, which is eventually doing the same thing or solving the problem, but it's offering different amounts of efficiency there, right? So if you're curious about where these millions and millions of people are actually fitting in, I think we have to understand this by first looking at the growth of Jupyter Notebook, right? So I told you it came out in the year 2014 or somewhere around 2015, right? So in fact, in its first year or in 1 or 2 years of its infancy, there were 200,000 users who started using Notebook in 1 year of Project Jupyter, putting out the notebook. But it's not that. Listen to this. Right from 2015, which was 6 years ago, from then to 2018, right? There was such a huge spike. There was such a huge increase in the number of users that we're talking about. We have 3 million notebooks. In fact, 3 million notebooks were shared in the year 2018. If you're thinking about 2021, I definitely would believe that this number has doubled or tripled in itself. We are talking about it in the millions, and I'm aware of that. Right, that's how popular it is. Everyone, people from Google, Microsoft, IBM, Bloomberg, right? I don't want to name all of these companies, companies, and of course even certain fantastic universities across the globe as well. So wherever you see on the screen, right, understand this: everyone from Google, Microsoft, all the way to NASA make use of Jupyter Notebooks, right? And in the research side of things is where you see a lot of the names of these universities, right? Northwestern, NYU, Berkeley, be it something like Clemson, Michigan State, and all these, right? So research, universities, individuals, startups, and even multinational corporations. The net worth of the companies in the first row itself should sort of, give you an understanding of, hey, if these guys are using Jupyter Notebooks, I think it's fine, right? So that kind of a thought process should help you understand. It's not just the thought process that's going to help you. This is an open source community where, if you're a person who's new into using Jupyter Notebooks, new into using Python, you definitely will be welcomed really, really well in this community with open arms, regardless of your proficiency, of how well you know Jupyter Notebook. You might not even know how to click a button, on Jupyter Notebook. So there are people who definitely will help you, right? So I definitely want to, welcome all of you all at the end of this tutorial to actually be a part of this community that we have, right? The Jupyter Notebook community across the world. It's not a website, it's not a group or anything like that, but it's a place, whenever you're talking about Jupyter Notebooks, you can find help on millions of websites out there regarding, right? Any websites, be it Stack Overflow, be it Quora, or any of these places where you can ask questions and get answers to them. Well, you will be welcomed with open arms there, right? Now, coming to an important part of this particular session, how do we go about installing a Jupyter Notebook to work with, right? Now, I want all of you all to follow along with me here, right? I'm just going to guide you about what to do, what to download, and how to set it up. Let me actually discuss about it a little bit and we can get started. First of all, to install Jupyter Notebook on your machine, there's an important prerequisite you guys have to concentrate about. Well, even though we've mentioned this, right? There are 700 programming languages, out of which Jupyter supports 40, which is again not a bad thing. But when you're taking a look at the 40 programming languages, let's just say I want to work with something else apart from Python. Now I'm a R programming language guy and I've installed Jupyter Notebook to work with. But a catch here with Jupyter Notebook is that it compulsorily requires at least one kernel to work. When I say kernel, you're going to understand when we're talking about it practically. This is where, right, even though Jupyter supports multiple programming languages out there, Python actually is a compulsory requirement for you guys to go on to work with, right? Either you use Python to install Jupyter Notebook or you use a distribution which provides Python alongside a Jupyter Notebook, right? There's only two options of how you guys can go about this. Of course, there's many ways of how you can install it. The simplest ones are these, but either way, regardless in both the options, you will have the presence of Python, no matter what, right? That's an important thing. Now, the next question you might have might be saying, hey, okay, so if you're installing Python Jupyter Notebook right now, or any Jupyter Notebook for that matter, right? I'll repeat this entire thing. Alright, so now you might have a question saying, are there any ways to install, or is it just only one way that we have to install? I just answered this question previously, right? There's many ways to install, but I'll showcase to you guys two very interesting ways to solve it. Now, one is installation using pip. Pip is basically the Python's package manager, right? Python Programming Language packaging manager is actually called as pip. And then we have Anaconda. Anaconda is the distribution environment that I was just talking about, right? Now, installing using both is actually possible for all of you all, regardless of your experience with Python. But to install it by using pip, as in the Python's package manager, well, think about it for a second. I told you require Python to install this, right? So if you're installing a Jupyter Notebook using pip, you must already have Python configured and ready to use so that you can use it to install Jupyter Notebook, right? There's multiple commands here. In fact, you have two very important commands that you guys have to use. The first one says install upgrade pip. This is where you're actually installing the latest version of the package manager, because if you have an older version of package manager, it might not install Jupyter correctly, right? So make sure you guys are using the latest version of PIP, and once your PIP is updated to the latest one, next you can run a very simple command called pip3 install Jupyter. Now if you guys are working with any other Python version apart from Python 3, right, so you can just use pip install Jupyter there as well. Pip3 install Jupyter is a very simple command, and I think it's very easy to remember as well, right? Pip install Jupyter. Jupyter again, it is Jupyter as you've been seeing, right? So it's two commands. If you guys have worked with Python, this is a breeze to install. Now let's talk about a situation where you might not have worked with Python and you might require some help to do it hands-on, right? So this is where we will go on to use Anaconda. Now let's go on to talk about how we'll use Anaconda for this. Alright guys, so the first thing that we have to do is we have to make sure that we go to Google and we ensure that we have Anaconda, right? I'm going to showcase the steps for you guys. It's very simple. Whenever you are searching in Google, just type for Anaconda. As soon as you type and search for Anaconda, as you can see on your screen, the first thing you will come up with is the distribution themselves, right? Now, I'll walk you through Anaconda's site as well, but there is a very simple way of how you guys can navigate around it, right? Now, it's the first time that you guys are seeing Anaconda. You have to understand that this is a paid product, right? So they have multiple versions and it's a paid product. But at this moment of time, remember I told you that Jupyter Notebooks are free to use. You're just using Anaconda's distribution to install Jupyter Notebook, right? So that is where, I'll just come back to Google here. I'm searching Anaconda here, and you can see this thing called individual edition, right? Anaconda individual edition, or you're going to use this URL as well, anaconda.com/products/individual. This is the toolkit that you guys want to install. Right now, this is the toolkit which again comes with all of the. So this is what I'm talking about, right? If you're working with respect to machine learning, you'll have a library such as NumPy, SciPy, Pandas, Scikit-learn, again a fantastic machine learning library. So you have an access, an uninterrupted access, I want to say, for a lot of these different things, right? Even the deep learning tools such as TensorFlow and PyTorch as well. Now the thing that you really have to do here is simple, guys. Just click on the download button here, and it's going to ask you, and it's going to take you down to the version that you guys have to install. Now, we were going to talk about this, but now that here we can actually finish the discussion. As you can see on your screen right now, Anaconda is available for all of you all who use Windows. For of course all the Apple fans, it's available on Mac OS as well. And for all of you all who are using Ubuntu or any other flavor of Linux as well, well, good news, you guys can have access to Anaconda as well, right? Now, I'm using a Windows machine, as you can see, so I definitely want to download the 64-bit graphical user interface, right? It's basically giving me a setup to do it. Let me go to the, let me actually show you. So as you can see, it started downloading, right? I just actually want to cancel this. You just saw that it was 500 megabytes and it took 3 seconds to download 500 megabytes, right? I have a very fast internet connection, but I didn't want to download it again because I already have it. Now, alright guys, so I've already installed Jupyter Notebook, but then I'm running it through with you guys again, right? So you'll be welcomed with a screen such as this as soon as you download the tool. All you have to do is click on next, click on agree because you have to agree with the license agreement. And here, depending on either you're working with your machine, your office machine, which might require an admin privilege, right? You can select all users, but as soon as you click on all users, it's going to ask you for the administrator right? Now, as soon as I go on to click and give it the admin right, it basically is going to take you to a next screen where it's just going to hit install and you are done with installation, right? This is literally as simple as it. I'm quitting it right now because I already have it, right? Now, in fact, what were the steps that we just did? Can you guys take a second to go on to just think about the steps that we did, right? Let me open up the steps quickly. First of all, we are going to begin this by installing which edition of Anaconda? The individual edition, right? It's somewhere around 500 megabytes at the moment of creation of this particular video. Download it. It's a very easy to install setup, and as soon as you finish your setup, I'm going to show you where to go about, right? It's literally as easy as opening your start menu and just starting out with your Anaconda or even your Jupyter Notebook, right? As we discussed, the individual edition, of course, Jupyter Notebooks in general support multiple operating systems here, be it Windows, be it Mac OS, or be it Linux as well, right? Now here it says, welcome to Jupyter. This is the Jupyter dashboard. Now let me just click on my desktop. I'll click on start, and on the start, can you see these two things that have popped up here? Jupyter Notebook, Anaconda, PowerShell prompt and all of that. The first thing that I want to do here is open Anaconda PowerShell for all of you all, right? Alright, so I just clicked on the Anaconda PowerShell prompt. In case if you don't have access to this, just click on start and type Anaconda, right? And as soon as I typed Anaconda, you'll get Spyder, you'll get Navigator, you'll get prompt, and you'll get a lot of other things, including a Jupyter Notebook as well, right? This is one way of opening the Jupyter Notebook. Now, what do you think is the command to open a Jupyter Notebook from the PowerShell, right? It's simple. All you have to type is Jupyter Notebook. And hang on, there's a small typo here. You have to be very careful, of course. These are all commands, right? So Jupyter Notebook, hit enter, and guess what? It should start out with our notebook in just a second here, right? Now, it's an important thing for you to understand that, hey, do I have to use PowerShell to go on to do it always, right? Okay, guys, as you can see, it took a couple of seconds, I think around half a minute to actually open from the PowerShell to open up this particular page. And this is your first look at a Jupyter Notebook, right? In fact, this is not a notebook. This is a Jupyter dashboard, as we would call it in the notebook, right? Now we opened it up using one way, right? I mean, it's a very simple thing that we did where we went to the command line, at the PowerShell, and we opened it. Let's try the other way of opening. But then before that, I want to make sure I want to close Anaconda completely. And after that, I'll just go to Jupyter Notebook and hit enter. So all that is doing is the same thing which I did manually. It's going to open up a prompt. It's going to open up a Jupyter Notebook command, and here it should say, hey, welcome to Jupyter. Right? This is the super amount of convenience. And in the background, if you see, you will have this notebook which will be open, right, ladies and gentlemen? This, make sure you guys are not closing, because if you close this, this entire concept of Jupyter Lab or having access to connect with our kernel itself, right? We're using Windows and all the processing power of my machine to solve all the Python applications there. I'm not connected to the Google Cloud Platform or let's just say AWS right now. This is where you need a connect from Windows to your Jupyter Notebook. For that, you really have to have this open. If you close this, your Jupyter Notebook will cease to work, right? It'll basically log out of the kernel and it'll have no access to run the code for you. So let me minimize this. Now that we have actually installed a Jupyter Notebook, the first thing we have to do is let's just try out if it works fine or not, right? Here on the right, let me zoom in a little so that you guys can see what's going on. Of course, you'll see the Jupyter logo there. You're going to see the Jupyter dashboard that looks like this, where you'll have files, running clusters and all of that. So let's quickly talk about everything from the top. Quit basically closes Jupyter Notebook, right? It closes. This is basically a server client architecture where your Windows machine acts as a server and you using the notebook becomes a client there, right? So quitting this will ensure that it removes the link with the server, and of course logging out will ensure that you log out of the servers themselves, right? Servers as in the servers that in fact we ourselves just created, right? What's running here. Now what you see here is basically a snapshot of my folder, right? If you go to C drive users, and in my case if I go to C drive users Anirudh Rao, this is exactly what I will see there, right? It's just giving me a dashboard. You can change this. This can point to C drive, D drive, E drive on default if you want, but since it was just installed and it really isn't configured, it shows you this way. It'll show you when the file was last modified, the size of the file as well. It's not showing the size of the file because we're talking about folders here, right? Now in fact we're going to discuss about all of these things. Let me click on new, the button on the right. You guys see it here, right? Let me click on new, and it's saying, hey, what notebook do you want to open? Here if I had installed R programming language in Scala, it would give me 3 options to say, hey, you can either open a notebook in Python, basically using the Python's kernel. So guys, from the home page, we clicked on new, we clicked on Python 3, and here we are at our first Jupyter notebook, right? Now, we're going to walk through what happens entirely, but the first thing that I want to try is to see if Python is working or not. Now, what is the standard way to check if Python is working or not? Right, we either type in a message, we type, you can just do whatever you want, a simple Python code to see if it runs, and let's check. Print, welcome to Great Learning. Ladies and gentlemen, welcome to Great Learning. We have installed a Jupyter Notebook with probably 2 or 3 clicks of a mouse button in a very simple fashion, right? Now, to get to the demo, I have to make sure that you guys understand the interface that we are working with, right? First of all, I hope all of you all are clear with the home page. On the files side, basically it's showing you all the documents. For example, if I click on desktop here, it will basically show you if you have any Jupyter Notebook files. You remember when I told you about a Jupyter Notebook file having the extension IPYNB, or the .py file is basically a Python file. You can see that we have something here on my desktop. It's called as Jupyter Demo, and it's a notebook that I created for all of you all, right? Fantastic. We're going to check that out. As you can see, it'll give you the file size here as well. Let me come to the next tab here. The next tab talks about the current running Jupyter process. Since this is a server client architecture, right now there is no other Jupyter terminal that are running, right? We're not working with any of the terminals directly, but we have a notebook that is open untitled .ipynb, right? So I can shut this down, I can close this. So I can do, when I say shutting it down, we're talking about kernels a lot. So let me quickly give you an idea about a kernel. A kernel is basically used to ensure that the computer itself in its most the CPU understands how to execute Python and how to execute Python and ensure that Jupyter Notebook also gets it, right? So that is where we require a kernel to actually sit and work with the phone. In fact, all of your mobile phones, right? Since it's working on Android, or in fact even on iOS, it will have its own kernels as well. It can be a single kernel architecture or multi-kernel architecture. That's an entirely different thing. Next, we have clusters. Clusters is basically when you're using IPython and you're using it in the parallel mode. That is again not the item of the agenda, so we are not going to cover that, but it's fine. For you guys to get to a very advanced level is when you will be using clusters. But for you guys beginners, if I try to cover clusters and show you a demo on that, there's a good chance you guys might get confused on it, right? Okay, now we are done with this particular thing. We realize that, hey, Jupyter Notebook is working and all of that, right? So let's actually go on to take a look at the demo here. First of all, let's take a look at everything here from the tabs and the options that we have. Take a look at the file option. Here you can create a new notebook. As I told you, if you had R language installed as well, you'll get an option to either choose the Python kernel or another kernel itself, and then you can actually open up a Python notebook, as I told you, using the dashboard. Then you can make a copy of it and you can actually save it as untitled copy. Just clicking on it will save the entire notebook into one. You can save, you can select save as. Save as is basically you can give a notebook directory / desktop. Maybe I just want the notebook to be called as Anirudh, right? You can do that, and then you can rename the notebook. You can save and checkpoint. So this is a fantastic feature we have to talk about. Checkpoints. Checkpoints is when you actually work on something and you have that as a safe zone in case of something in the future. If you're working on the same code, if you mess something up and you forgot what you changed, where you changed among a lot of lines of code, you can actually revert back to a checkpoint, and all the code which was present at that time, right, it's going to be as it is, and right, even though you've been working and modifying it 100 times, as soon as you roll back to that checkpoint, all of your code at that moment when you saved that checkpoint is going to be intact, and that will be the version that you're going to see, right? Revert to checkpoint is exactly that. Now we don't have any more checkpoints because we just created this notebook, right? You can print it and you can download it as well. Look at this. This is where another huge advantages of Jupyter Notebook lies. So as soon as you click on download as, it will give you multiple different options. You can download it as HTML, download it as JSON. In fact, it uses JSON a lot to work, right? So you require this, you require JSON, to be very honest with you, since we're talking about not just program level or programming language level independency, but we're also talking about operating system independency with Jupyter Notebook, right? So that's where it's important. Next is close and halt. As soon as I click on this, it's going to halt the server and it's going to close the Jupyter Notebook, right? Then coming to edit. Edit is when it's giving you options which you might have not seen in Python before. Cut cells, copy cell, delete cell, split cell. What is all of these options, right? In fact, what you see on your screen right now, ladies and gentlemen, is a cell. In fact, let me delete, the cell. Fine. Now we have one cell. This is actually a code cell. There's multiple types of cells that you can have, right? For example, let's take a look at something called as a markdown cell. So if it's a markdown cell, it's basically an explanation, or you can use HTML here directly. You can use an HTML tag directly here to either have a heading, subheading, add your images, add your videos, or whatever it is, right? Also, you can similarly just use a hashtag. Hashtag will give you access to multi-levels of heading here. For example, this would be heading 1, right? Heading 1, you can see that it's pretty big in the size. Now, if I just do it again, this is heading 2, right? I'll do it again, but with this time with 3 hashtags, and now it's heading 3. I guess you guys are understanding where this is going, right? Now, for all of you all who might be confused saying, hey, isn't hashtags used for adding comments in Python? They are, but right now this cell is not being treated as a programming cell, but this cell is being treated as a text cell where you can put any text that you want, either in HTML format or even in rich text, is exactly what we did as well, right? So these are like the multiple sizes and levels of headings that you guys can get whenever you're working with it. It doesn't have to be heading, right? So you can just type anything you want. For example, step number 1, we are going to use Jupyter, right? So we can have something such as this. This will not run. Even if you click on run, nothing will happen. It'll just come as a text there, right? Because this is a text box. This is not a code box. Next, we're going to take a look at a code box. Basically, the same example that we did right here. Let's just say hello world. And here you can see that there's a slight difference. Here it doesn't say markdown anymore. I can have it as a markdown as well, right? Now, as soon as I hit run, this is a text, but I want it as a code. So all I'll do is click on code, and now I have it in the code snippet, right? Being here is very simple. Now to execute this, what do? It's simple. There's a very big play button or a run button that you see. You click on that, it works. But is there any other way? Are there any other shortcuts? Well, I'm glad I asked the same question, because if you take a look at it, it has a ton of shortcuts, right? Instead of actually, hitting the run button every time, all you can do is hit Control Enter, right? If you just click on that tab and hit Control Enter, you'll actually go on to run it and execute it fine as well. But there are 2 color modes which you guys have to pay really good attention to. Is this one? Look, the bar on the left side, can you see it is blue right now? It is telling that we are in an execution mode, or we are in a mode where we can either modify the cell. So this is cell operation. Either execute the cell, delete the cell, or move it around top to bottom. But what if I have to go into the mode where I have to code it, right? Let me just click on it. One mouse click on the text bar, and you see the entire thing became green right now. Let me zoom in so all of you all can see. Can you see that the entire thing is now green on the left side? This is when we have gone on to edit mode, right? This is edit mode in a way where you can actually write Python code and it will execute. Now, what if I add a couple more of exclamation marks, hit enter, and hello world is there, right? You saw this. This is how you can move it. No, I'll repeat that. So this is how you can work with a single cell in the edit mode and of course in the view mode as well. But the other thing that you really have to know is, let me have here another cell for you guys, right? First of all, what we can actually go on to do is find out the version of Python that we have installed, right? We installed Python, we verified that it's working fine, but we actually left it at that. Can we go on to verify and check the Python version that's installed for us, right? On the right, it's telling us that it's Python 3, but hey, Python 3 point what? There's multiple versions there, right? So let us, go on to check that out. So guys, I'm going to type in the piece of code now, right? So from platform, import Python underscore version, right? Now this is a function that I'm actually calling that's present in platform for us. So I need to call the function. So I'll just say Python underscore version here. And since this is a function, of course, the parenthesis is important. Now I showed you guys a shortcut. I just hit Control and enter, and you can see on the screen that it's giving me saying, hey, you have Python 3.8.8 installed, right? Pretty simple. Of course, you can find that out here as well. You can find out a lot about, especially this help section is fantastic, guys. You can get a tour of the entire user interface, all the keyboard shortcuts that you need. Right now, for example, I can actually go on to delete this entire cell, not by pressing a delete button, not by going around somewhere selecting options. I just double click on D, but then I do not have to be on the edit mode. Right now, see, it went green. This is the edit mode. If I type Ds, it is going to show me Ds on the screen there. So what I'm going to do, I'm going to make sure I'm not in the edit mode. That's when it's blue color, right? Now that it's blue color, if I double press D, I don't single press it. If I single press it, nothing happens. The key D, I double press it and boom, it deletes it, right? That's pretty simple. In fact, even to add cells, right? You particularly have the examples as well. If I press A, it will add it above the current cell that I have. And if I select the cell and type in B, it will basically add it below. So with the cell that you have selected, if you press A, it's going to add one more cell on the top as in above, or if you select B as in below, it's going to add one more cell below to you guys, right? Now, this is when I pressed A, this is going to be a comment, so it's okay. I pressed A and this cell is above, right? And I pressed B and this cell is below. Right? This is a pretty simple example. You can see that I'm not taking very complex programming examples here for you guys to understand, right? But then this is a simple Jupyter Notebook interface where you can, work with it. You can save files. You can add a cell, basically cut cell. You can even cut and paste cells as if there were, files, right? You can move it around with the arrow keys. For example, if I'm moving this around, I can do it as well. Run, stop, rerun, or this last button is actually fantastic. You can restart the entire kernel and run every single piece of code that you have from the first to the last, right? That's an important thing. And then it says that this is a trusted notebook. If it says the notebook is not trusted, or if it's from an untrusted source, you'll have to trust it first. Only then will the kernel connect to run. Right? Again, multiple options in the view. It's very simple. You guys, toggle header is basically either removing that Jupyter Notebook untitled, right? Instead of it saying untitled, let me just say great learning demo on Jupyter, right? Jupyter. Fantastic. Now I renamed it, right? Rename it. I'll click on save and this notebook is saved. So if I have to remove that particular header, I can just click on view and toggle header. Toolbar is the same thing, right? You either want the toolbar here or you don't. You can select it. You can have code line numbers as well, right? You can see that it says line number 1. Now it will say line number 2, line number 3, 4, 5, 6, 7. Can you see that? I can either have this on or have this off, right? There's a keyboard shortcut for it. It says Shift L, right? Let me just try Shift L right now. And hey, line numbers work. Now I'm a person who prefers line numbers on, so I'll just leave it as is, right? Fantastic. Now, what's the next option that we are going to look at? Sorry, I clicked on that. Yes. Right. So we ran all the cells. You can select a cell and run all the cells above it, or you can select cells and you can run everything below that. You can run all the options. You can manually select the cells to run and all of that, right? So you can convert this from a cell type from a code to a markdown, right? As soon as I converted it into a markdown, it basically went into being a big in blue. Right, again, let me make this code. It's a comment. Again, it won't matter. But then you have to see the difference. This is a Python comment, while this is not a Python comment, this is a markdown, right? Even though I've just used the same hashtag there, that's something you have to know. And then talking about the kernel, yeah, this is when you interrupt the kernel with a double pressing I, you can restart the kernel, double pressing 0, you can restart and clear it, shut it down, change the kernel in case here you're writing a piece of code that's working in Python. Maybe the next notebook you're working on is R and you just want a quick switch. All you do is click here, come and click on R and you're done, right? The next thing is something called as the widget states with respect to Python or with respect to Jupyter in general, right? So Jupyter widgets are super popular, but I want to make sure that you guys do not get confused with using widgets right now. If you're very much curious, let's definitely have a session where we're going to create widgets, save it, start using widgets on it as well. But then if you guys are beginners, it will confuse you out. Right? Fantastic. Now, we already saw the keyboard shortcuts. You can edit it. You can have your own shortcuts. You can get help with respect to Python, IPython, NumPy, SciPy, right? I really just basically open up their own website. I just clicked on Matplotlib, so it's opened a Matplotlib website there, right? It's pretty simple. But then did you guys notice one important thing when the Jupyter notebook opened up? Look at, let me zoom out, right? Look at the URL, the uniform, the URL here, right? It doesn't say jupyternotebook.com. It doesn't say any website's name. It doesn't say Google. It doesn't say Facebook. It says localhost 8888/tree. Now, what is localhost? With the port number 48, right? So it's basically talking about this machine itself. We are in a server client architecture right now. In fact, if you're in a network, you can have your office server actually run your Jupyter notebooks for you, and you can have individual clients connect to the same server and work with it as well, right? Since the server and the client, in my case, are both on the same machine, it is basically opening up the local host. This would be the address of that particular IP address or network, wherein if you are in an actual server client architecture where the server and the client are two different computers, right? That is when you'll see something else. But right now, what you're seeing is basically self-addressing, that is localhost port 48, right? Fantastic. Okay. Now that we have understood what each of these options does, don't you think it's high time we open up a pretty complex Jupyter notebook to see if we can make use of the modularity to talk about the advantages and all of that? Well, what are we waiting for? Let's get started. Let me click on File. Let me click on Open, and now basically it just gives me a dashboard, right? I can actually close this. In fact, I can just close it like this. It's going to have an instance running, which eventually we can close later. Now, where is my file? It's in the desktop. I'll go to desktop. I'll click on jupyterdemo.ipynb. As soon as I click on it, ladies and gentlemen, welcome to my Jupyter notebook. It's a very simple data science demo I have for you guys here, right? If I just go to 100% this thing, the font, it'll be very difficult for all of you all to see it, right? Look, it just looks so tiny. I understand that a lot of you all, who tune in from your mobile phones might have a bit of a difficulty to take a look at it, right? So that's the reason why I'm going to zoom in when I'm explaining, right? Now, I can see that all my previous outputs are seen, right? So I just want to remove all the outputs. So I just go to all outputs in the option cell. I go to cell, I go to all outputs, and I say clear all outputs. Now you cannot see any of the outputs, right? Fantastic. Okay, so what is the first thing we need to do? We need to trust the notebook on the top right. If it's not trusted, in this case, it's my own notebook. Of course, it's trusted. So we can actually go on to start executing this, right? This is where I'll tell you, ladies and gentlemen, it's super simple to work with. First of all, what is it? What are we doing here? Let me give you an overview of what it is that we are trying to achieve in this particular demo quickly, right? This is a data science demo, basically where we are using machine learning and a lot of statistics to understand what are some of the features or what are some of the situations and trackable metrics that will cause diabetes, right? So I'm going to have a machine learning algorithm, see if it can perform predictions by using a lot of patient data, and can it tell me if this person is diabetic or not? Of course, in the real world, we will know, right? So me as a programmer, I will know if person A has diabetes or not, but my machine learning model will not know it. So it has to guess. It has to sit and use data, understand it, work on correlation, use machine learning algorithm to see if it can understand it. I know that person has diabetes, yes or no, I know it, but the machine has to tell me, hey, I think I have such and such percentage of probability that this person might have diabetes. You will understand more as and when we go on, right? To go on to achieve this model, we require a lot of data science libraries, of course, like NumPy. NumPy is fantastic. It's called numerical Python. It's absolutely necessary for handling any sort of numerical operations in Python. Then we have pandas, which offers two beautiful data structures for us. One is called as the series. the second one is called as the data frame structures, right? Fantastic. Next we have Matplotlib, Seaborn. Matplotlib and Seaborn are two data visualization libraries where in case if we are working on graphs or we're working on any sort of visualization, this is the library you're going to require. Now, why do I have it here? Because I have graphs for you guys to show, right? And the next we have is sklearn. Sklearn, or is also called as scikit-learn, is the heart of the entire machine learning library, is what I would like to say for Python, right? Now we understood the first what's happening here, right? Of course, you can see that from these libraries, I'm basically trying to import a lot of different things. Now we are not in the edit mode. The green one is the edit mode. The blue one is the working mode. So I just hit Control Enter and it's showing a star here, right? So if it's showing a star, it means that it is still executing. Please wait. Once the star becomes a number, that is when your code segment has executed, right? For example, at this moment of time, this code segment, all we're trying to do is we're trying to import all of these libraries, so it should take a second. Well, there you go, right? It went from a star, it went from the asterisk to 1. If I execute it again, what will happen? Well, 1 will just become 2. 2 will just become 3, 3 will just become 4 if I keep doing it, right? So all I'm trying to do is give it an attachment, give it a number where it's I'm just finding out the order or the number of times I've executed, right? Now the next thing that we're going to go do is actually use pandas to import this data set for us. Now this data set lies here, right? I have to give the path for the data set. It's in C drive, users, Anirudra, that's my name, downloads, and diabetes.csv. This is a file that I want to use. So what I'm going to do, I'm going to hit Control Enter, right? As soon as I hit Control Enter, you can see that it shows 5. It shows 5 basically because here it's 4. We did it 4 times, right? Now the data set is imported and it's ready for us to look at. So what is this data set that we are talking about, right? So look at this. As soon as we use the .head method, we can look at the data set. Now, whenever you're thinking about diabetes, ladies and gentlemen, there's many causes that can lead to diabetes, right? Everything from pregnancies, glucose, of course, blood pressure, skin thickness, insulin, body mass index, all of these things, and of course, even age can have an impact on diabetes, right? So wherever you see zeros here, it means that this patient does not have diabetes. Wherever you see 1, it means that this person has the diabetes. This last column, the outcome column, we will see it, but when we are providing it to the machine learning algorithm, we will not provide it unless we're testing it, all right? Okay, fantastic. Now, what we're going to do the next thing is we're actually going to try to print all the columns that we have. As you can see, pregnancies, glucose level, blood pressure, skin thickness, insulin, and BMI and all that, right? A BMI of 25, I think, is considered as the standard to say you're fit. Anything more than that is usually considered as fat, and then it's obesity and slightly obese, completely obese. For example, a body mass index of 43 means that this person is extremely obese. You can see a lot of insulin value in there. You can see their age. I wish this also had their weight as well, right? Because as soon as I look at that body mass index, I can sort of guess that this person might not be getting in a lot of workouts or might not be burning the calories. So there's a good chance he or she might have diabetes, right? So this I can guess. Now I'm going to use my machine learning algorithm to use all of these features to actually go on to give us a prediction there. And these are all the columns, right? I'm just printing it out to give you details about it as well. The next thing that I did here with data.info was to tell you that, hey guys, listen, we have 768 patients worth of data where we're actually going to do this, right? Fantastic. Now you know how many people we have. 768, right? The next thing is basically a statistical description of what is going on. It says statistical, it's actually statistical. I'm sorry about that. Okay. So with the statistical description here, you can go on to see that you can find details about the count, as in how many rows of data are there for these particular columns. What is the mean of each of them? What is the standard deviation, the minimum value, 25th, 50th, and 75th percentile, and the maximum value as well. So if you just wanted a quick statistical look at the data set, all you had to do is just click data.describe. Of course, data being where our data frame is there, right? So the next thing that you go on to do after just taking a look at it and understanding, right? Now, you might ask me a question saying, why did you do this? Well, I just wanted to take a look at the average body mass index of the 768 people I have here. Well, I can get that with 1 second. I just looked at it and I got the answer, right? So it's 31.9. This is for 768 people all in total body mass index. So the next thing I want to do is I want to see if I have data for all the 768 people. If any of these were to be true, it's telling me that, hey, there is not a number, there is something else apart from a number in these particular rows or columns of data, and please fix it. Since all of it says false, basically my data set is pre-cleaned and ready to use, right? So the next thing that we're going to take a look at is correlation. Let me actually execute this. This will give you a fantastic looking output, as I just told you, right? Let me go on to go a little zoom out on this, and ladies and gentlemen, look at this. This is basically what we call as a heat map or a correlation map. Right now, this is a very important map, even though it just looks a little funky for the people who might not know data science. Even though it just looks like a lot of pixelated color blocks, it is actually giving me a ton of information, right? I would rather use this to get the information rather than looking at something like this, right? Of course, this is basically what we're trying to do is we're trying to map a relationship, a correlation, a positive or a negative correlation between two of these features that we have here, right? For example, is blood pressure related to glucose? If you ask a question, take a look at glucose, take a look at blood pressure here, it's this. So it's slightly darker color of purple. It's telling me that there is not much correlation. Find a light color. Hey, here's a light color, right? It's between skin thickness and insulin, or in fact, insulin and skin thickness. These are mirror images basically, right? So it's slightly pink because it's telling me that, hey, these two features have more in common than the other, right? Of course, these are all in-depth data science concepts. Do not worry if you don't understand this. But one last thing about a correlation matrix is that whenever you try to compare the same thing, it will give you 100% similarity, right? That's why all these elements on the diagonal are white. White means 100% positive correlation. Of course, if you're comparing pregnancies with pregnancies itself, there is no difference. If you're comparing glucose with glucose, no difference, right? That's the reason why all of these are white. Fantastic, right? Now let's not get into too much of the detail. Let's quickly get to understand how many people have no diabetes out of 768 people. Well, 500 people don't have diabetes. That means 268 people have diabetes, right? So we know how many people don't have diabetes and how many people have diabetes. Let's quickly plot a graph to showcase. This is where we require libraries like Seaborn and Matplotlib as well, right? Look at this. You can see that if it says 0, if the outcome is 0, it means the person does not have diabetes. So we have 500 people with no diabetes, but 268 people with diabetes. Now, the next thing what we usually do in machine learning is we split the data into testing data set and a training data set. It's just like you guys in your college are giving an examination, right? So you use the textbook to learn and eventually you give out the answer paper after the examination to the teacher, right? So that's when they use your answer paper to evaluate your performance based on your learning from the textbook, right? So here our textbook is basically the training data, and the examination, the test we're going to perform on it is basically called as the testing data. So you have to split the data set so that when you're providing the test data, it sees an entirely new data which it has never seen before. That way it can predict accurately, right? Simple. So all I'm trying to do is I'm splitting the data 80% for training, 20% for testing, and as soon as I click that, it's done. The next thing is where we actually use linear regression. Now, for all the people who might have never used machine learning, who might have never used data science, if you were wondering saying, hey, this guy is showing us a machine learning demo, it might be a really long demo with probably hundreds of lines of code. Not really. All these 3 lines of code is exactly what is necessary to perform the entire machine learning procedure. This is when I'm calling the machine learning algorithm. Basically what we're trying to do is logistic regression. Logistic regression is a supervised form of learning for all the people who might know it. And then we perform model fitting. This is the exact step. This line of code teaches the model how to predict. The next thing is where I try to see if the model has understood anything or not. Let me hit Control Enter. It'll actually give me a warning where it says total number of iterations limit. As in, it's just said that, hey, you can increase the number of iterations, and we have basically reached a limit where it's trained so many times already, right? It didn't even show us anything that it's training and it's already trained. Of course, the next step is to perform predictions. I click on it by passing the testing data, right? Now at this moment of time, I actually know what's going on with respect to my model. If I print something called as a confusion matrix, now for all the people who do not know, these 4 really funny looking numbers will give me everything I need to know about my model. If someone just gives me these 4 numbers about their machine learning model, tells me the problem statement, tells me, hey, these were the use cases and this is what we have done, I can tell you if your model is performing really well or not. In fact, you just give me 4 numbers, I'll tell you if your model is probably doing great or where it might require some help as well, right? So this is a metric which tracks values in terms of what actual values are versus what the predicted values are, right? So it's a comparison where we're attaching a metric called as true positive, true negative, false positive, and false negative. So each of these numbers have a meaning. Now, I do not want to get into the detail of it because it might confuse you, right? Now, the last step is to find out the accuracy. Now, my machine learning model is trained, but how accurate is it, right? As soon as I click on Control Enter, it's telling me that, hey, out of every 100 patients, for 75 patients, it can guess exactly right, saying this person has diabetes or this person does not have diabetes, right? So it's a 75% accurate model. In my books, this definitely works, right? Because all we're trying to do is we haven't even shown if the person has diabetes or not to the machine learning model, but machine learning was intelligent enough to understand, saying, hey, okay, so all of these things, I see a common pattern here. So it builds a couple of patterns, it uses the algorithms to learn, and it can give you a probability of guessing if the person has diabetes or not, right? Now, we did all of these things in a very modular approach. You look at that, right? Now, let me remove all the outputs again. Let me clear the outputs and look at this, right? You see that we have how nicely we have each of these in a single tab. You imagine just having all of these in just one single tab and me trying to explain you guys, and at the end, I just have to hit one enter button and everything gets done. You really will not understand anything about what's going on. This way that I broke it down for you, of course, since this is not a data science demo, I just walked you through it really quickly. If this was a data science demo, we would talk about all of these things to a good amount of detail. But my point here was to make sure you can have this kind of a modular approach to go on to teach this, right? Last thing that we're going to discuss is the benefits of you guys using Jupyter Notebooks. You already know all the benefits by this moment of time, I am for sure. But let's quickly revisit it so you guys remember it, right? First of all, modular division of code, right? You saw how we can divide code into tiny bite-sized pieces, and imagine having that entire code snippet in one cell, and it wouldn't even be called a cell at that point of time, right? So modular division helps you immensely. This is a benefit you know about. Here's another benefit that you guys already know about at this moment of time, right? Jupyter Notebook is platform independent, as in you can work with it on Windows, Mac, and Linux as well. And of course, it's language independent, as in it'll work with multiple different programming languages like Python, R, Scala, and about another 35 or 36 programming languages. The next benefit, of course, it makes your entire process of writing code, and if you have to explain it to either a teammate or in fact enthusiastic learners like you guys, it makes my job a lot easier to see it in these tiny cells where I can just execute that cell and show you what it means, right? Now, it will not always work like with other programming languages. If you have a compiler based programming languages, you usually cannot divide it into cells. You can actually, there are many ways to do it, but natively you cannot do it. With Python, we can do it because Python is an interpreted programming language.
So, first we will have a look at what is Google Colab. Google Colab is a product of Google. So, we all know about Google, right? Google is a part of our everyday's life. So, it is basically a free notebook environment that runs fully in the cloud. Okay, so if you are an enthusiast who actually wants to learn data science, or if you want to do your coding in Python, then I should suggest you to go for Google Colab, because for this Google Colab is a IDE, that is Integrated Development Environment. And if you don't have laptop and if you don't have a proper configuration for your code, then the Google Colab is a solution for you. So it will help you to do lots of things in Python if you don't have laptop or if you don't have a proper features that required for your particular projects. Now we will have a look at why do we need Google Colab. So Google Colab is quite involved in the artificial intelligence research and development part, right? One of the most popular artificial intelligence frameworks was made by Google called TensorFlow, and also a development tool called Google Colaboratory. So if you already in a domain of deep learning and machine learning, I can assume that you have already heard about the term TensorFlow, right? Keras. These are the actual frameworks developed by Google. They also develop a IDE, that Integrated Development Environment, that is Google Colaboratory. right? And we also know TensorFlow is one of the most used open source tools since 2017. So Google Colaboratory was made free for public use by Google to encourage the AI enthusiast and the community well. Colaboratory is now publicly known as Google Colab or just Colab. Now we will have a look at what are the features is actually given by Google to use the Google Colab, right? So first, you can write and execute code in Python. Document the code which supports the mathematical equation. So if you want to put any mathematical equation in your notebook, that is supported by Google Colab. And also if you want to add some pictures, images or some videos, that is also supported by Google Colab. It's like a HTML. The way you write HTML, the same way you can write those equations and those those videos and those images. So your notebook will be proper end-to-end book, right? Then if you want to use a create new notebooks, you can do that. If you want to upload an existing IPYNB file, you can upload them and you can change them accordingly. And if you want to share the notebooks with the Google link, you can do that. The way you can share your Google Docs or Google Excel or PowerPoint, right? The link you have shared with the person, you can share this notebook link as well with your team. Now, import data from Google Drive. So if you want to import data from your Google Drive, maybe when you are going to work with a deep learning or we are going to use some machine learning project, that time if you have a big data, that time you can actually upload those data in your Google Drive and you can import those data to your Google Colab directly. So if you are going to use a GitHub repository, that time you can directly by using Google as well, right? And if you want to save notebooks from and to Google Drive, that is also possible. Now comes the import and publish notebooks from Google GitHub, right? So if you want to import or publish any notebook to your GitHub repository, you just need to log into GitHub and you just need to connect that to your Google Colab notebook, right? And you are ready to use them. Now comes import external data set from Kaggle. So yes, you can, if you want to import external data sets, that is also possible using Google Colab. Now integrate PyTorch, TensorFlow, Keras, OpenCV. That is also possible. If you want to integrate those things with your Google Colab notebook, you can do that. It's just a matter of a command. That's all you need to do. Now comes free cloud service with free GPU and TPU. So this is the main catch about the Google Colab. So why we use GPU and TPU, we will have a look at that as well. But yes, if you have a very high computational, if you have a data set or if you have a model that is actually required a high computational power, that time you should go for Google Colab. And that is also for free. Types of runtime we have in Google Colab. So total 3 types of runtime we have in Google Colab. One is CPU, GPU and TPU. Now we are going to see what are the specification we have for CPU in Google Colab. So for CPU, they are using model number Intel Xeon CPU, that is 2.30 gigahertz, and address sizes is 46 bits physical, 48 bits virtual, and cache size is 46080 KB. Let's have a look at the specification for GPU. So for the GPU, they are using single 120 GB NVIDIA Tesla K80 GPU. And it can be used up to 12 hours continuously. The RAM they are providing, that is 13 GB. Now we are going to look at the specification for TPU. So cloud TPU with 180 teraflops of computation, Intel Xeon processor with 2-core 2.30 GHz and 13 GB RAM. So these are the specification provided by Google to use your Google Colab repository, right? So these are the quite good specification, I can say you are getting free of cost. Now we will start with the practical part of how you can actually start with Google Colab and what are the facilities we are going to use over there. I will show you. So let's go to Google Colab. So after you came to your favorite browser, just write over there Google Colab, right? So you will get the first link over here. Click on the link and then you will get a window like this. Right? From here, you need to go for, if you want to upload a new notebook, then go for upload and choose your file from your local system, right? Maybe your file is in desktop or downloads or documents, wherever you have your file, just upload it, right? Let me just upload one of the file, for that you can understand. Okay. So Maybe this is my IPYNB file and I just want to upload it. Okay. And as well as I want to have a new notebook as well. Let me just do that. Okay. So you can see my notebook got uploaded. Now I want to have a new notebook. How can I do that? For that, what you need to do, go to file. So you will get an option called file, and from there go to new notebook, right? Yes, your new notebook is getting loaded. So you can see my new notebook is already loaded. What I need to do, I need to change the name of the notebook. So if you look over here, you can see a drive, Google Drive sign. So basically this sign is basically indicating whatever the notebook you are doing over here, that will be saved into your Google Drive, right? Now I want to change the name of my notebook. Just click over there, hover your mouse over there and write the your favorite name you want to go for. So for my case, I want to give demo. Now we will have a look at the runtime. Okay. So go to runtime, click over there and you will get a change runtime time option, right? Click over there and here you have a hardware accelerator. That is none, that is CPU, GPU and TPU. If you want to go for GPU, click on there and then save, right? So this is how you can start using GPU or TPU in Google Colab. Now I will show you if you need to write a code, write print and then maybe we will start with hello world, right? Let me just, okay, if you want to execute that, maybe you can use shift and enter. This is a shortcut. And if you want to use, if you don't want to use any shortcut, so you can see there is a play button over here. You just need to click over there, right? So you can see we got our new, we got our results, right? Now, if you want to add more code blocks over here, just click on this code plus sign. Click on over here, you will get a lots of code cell. Now I want a text cell, right? So why do we need text cell? So if you click over a text cell, you can see there are lots of things you will get. So maybe you will get a, if you want to use a H1 tag, that time maybe I'm writing that first demo, right? Okay. Yes, you can see this is a first tag and under this all the code will come. So if you want to use something called, if you want to bold it, the way you bold it, so in HTML that B tag and close this B tag, right? So this is the same way we do in Google Colab. Otherwise you will get a shortcut that is B. If you click on the B, so you, whatever you are going to write under this part, you can see the bold text that will become bold, right? Let me just write something you can see over here, that is bold text, right? So it's up to you. If you want to make a notebook with lots of questions, lots of images, you can do that. And if you want to import images over there, click on the images and you can import from here. So I have some of the images, maybe I want to use this. Yes. So anything you can do, attaching file or anything, right? So, or if you want to give some bullets points in your, the text box, you can do that. So lots of features you are actually getting when we are going for doing this part in Google Colab.
So what is Spyder? You might look at the name and say, okay, that's not what a spider is named after, right? But of course, it's not named after a spider as in the creature. It's actually, it has a full form. Spyder stands for Scientific Python Development Environment. As the name itself suggests, if you're a person who's working, in the domain of data science, if you're a person who's working in the domain of data analysis, right? This scientific environment will give you all the tools that are needed for the trade, right? Now, you might be a person who says, hey, now I don't have anything to do with data science or data analysis. Can I still use Spyder? Well, of course you can. It's a full-blown integrated development environment, but it had a niche purpose when it was built, and that purpose was grown out through the trend to a point where right now, if someone says, hey, I want to get started with data science, if someone says, hey, I want to get started with data analysis, what is the one IDE? If they had to pick one IDE out of all the choices you took a look at, definitely Spyder would be my recommendation there, because at the end of the day, this was built for that, right? Whenever something is purpose built, it will give you a huge set of features that is meant for those domains through which you can work, right? One important thing you have to understand to start out with, right? The first thing you have to understand about Spyder is that it is open source. It is developed by the community. it is developed for the community. Now, if that is not enough, you already know that it is developed for Python, but did you also know that it is actually written in Python in itself, right? So how Spyder works, it uses Python. What do you do with Spyder? You write more Python code. How amazing is this, right? So it just showcases the power of Python, and it showcases what you can do. Again, having a very good user interface, and of course having an IDE working with that, right? So understanding that with an IDE, you get these chances and you get access to such good features, which is absolutely not possible in a text editor, right? Now, whenever you're trying to enter something into a text editor, of course, the text editors these days, especially Google Docs or something like that, will go on to predict what it is you're typing. But even I don't think it would do the same if you're trying to write code, right? Because it has absolutely no idea what language you're writing in and all of that, because maybe it's not analyzing, it's not its job. The text editor is basically giving you a place where you can write down your text in a structured manner, save it, and be done with it, correct? But with an IDE, it's purpose built to make sure you have more structure. So coming to certain components of Spyder, right? Now, Spyder as an IDE has a lot of things that it's associated with. There's many core building blocks which make Spyder what it is. The first part is the code editor. Now, as I told you, a code editor is going to be very, very important, be it in terms of how you highlight the syntax, be it in terms of how it shows. Can you combine cells? Can you actually combine your piece of code into one element? Can you split it out? Can you separate it out as you prefer? All of these questions you're going to be having, and you can do all of that with the help of a code editor, right? It will give you this sense of freedom. It will give you a lot of leeway to play around with code, structure it as you want. Of course, you'll still have to conform to the rules and the syntax that's presented by the programming language. But apart from that, whatever you do, you have access and you have the flexibility to do what it is that you want with the language, right? That is the most important part of Spyder. Now, it's not just that. Since you're working with Python, I'm sure you're aware of something called as IPython, right? Interactive Python. Now, with respect to interactive Python, it will give you a console, which again can help you a lot. If you worked in Python programming language, you will know that IPython is absolutely fantastic, and the way you work with Python, the way everything, right from how easy the language is to learn, all the way to how it gives you. How it makes you understand errors, right? It's not complicated. It's not convoluted like other programming languages, wherein you were writing a piece of code, there was an error at hand, and you don't know what the error is because it's so complex to read. Not really. With respect to Python, the error is put out in a very nice way so that you understand where the error is. 99% of the time you can also guess what the error is, and there are IDEs in today's world which will basically also fix it automatically for you, right? That is how much we've progressed in the world of IDE. Now, coming to the another important component of Spyder, which is basically Variable Explorer, you have to understand that whenever you're working with a large amount of code, you might have more than one variable, of course, right? You can have hundreds of variables. Now, I myself have worked on programs wherein you have 300, 400 individual variables that you have to know what it is doing. You have to track it. You have to make sure you're not overwriting on something else, right? Now, all of this will happen if you have a structured way to code. We already understood that with an IDE, you can do all of that. So why do we even require a Variable Explorer? Well, a variable explorer will tell you a lot of information right from the inception, right from the creation of the variable until how you're using it, what values you've stored in that, what is the address of that particular variable, when was the memory allocated, when is the memory deallocated, what is the amount of memory that variable took. You can go into the depths of those variables. Of course, in all the cases, there's a very good chance you might not be doing that, but there are some cases where you require this kind of an in-depth look to figure out what is your variable doing. Maybe you just misassigned it, you're not able to find it out in the code. As soon as you open up the variable explorer, you will figure out that, hey, this was pretty straightforward, and you look at the variables and you'll be like, okay, so this value isn't supposed to be here, so let me just run through that variable, find it in the code and fix it, right? So all the attempts that an IDE is doing, which is eventually bringing you closer to again having a very structured way and a very efficient way to make use of your time, and for you guys to be as creative as you can with your code, right? So we said that Spyder is mostly for scientific usage. We said that Spyder is very popular for data science and data analytics. Now, whenever you're talking about these domains of data science and data analytics, you might have definitely seen, right? So whenever a data scientist or data analyst is trying to explain a solution, they will not show you they'll not show you a spreadsheet full of like 100,000 entries and tell you this is what is happening here. No, it's super complex. What they do is they convert all of that into beautiful looking visualizations, reports, plots, dashboards, and eventually using that they'll say, hey, this is where the problem was, this is how we have solved it, and maybe this is the insight, this is the forecast, something like that, right? So having ready access so that you can go on to work with it is a huge advantage. With the help of Spyder, you are actually getting access to multiple types of plots. And again, plotting for a data scientist and plots for a data analyst is super, super important, right? Not just that, and not just data analysis or data science, having a debugger which works really well is also key. As I told you, right? If you're trying to debug without the help of a debugger, what is it that you're doing? You have 100 lines of code, you run the code, there is an error, you go there, you fix the error, somehow you fix one error and it led to another maybe 20 errors, right? So you don't know why your program is behaving the way it does. In those cases, you just select those 10 lines of code, select those 20 lines of code which have an error, right? And you just say, hey, here's a start point, here's an end point, just execute it line by line and tell me what the program is doing for every line you execute. Having this kind of flexibility will help you fix errors at a lightning pace. Now, you might be a person who says, hey, executing it line by line, understanding it is a pain, right? It's going to take a lot of time. How is it more efficient? Not really. Once you actually start doing it, you will realize that having a debugger is probably the best advantage that an IDE can provide to you, right? And it's not just about debugging, it's not just about fixing bugs and ensuring you have an efficient way to work with. Sometimes it so happens when you're actually using a new function, when you're using a new method or something, you might not know all the parameters that the function uses. Or in fact, even if you know the parameters, there's a slight confusion in the name of it, right? Syntaxes of programming language, you already know. You cannot change one thing around and expect it to work. It has to be perfect, right? So when you're expecting that level of, when a programming language is expecting that level of perfection, and when you want to say, hey, I want to be perfect with my code, sometimes you're going to require help, right? No one is saying, hey, close all your textbooks. No one's saying, hey, close everything and just start writing code. No, whenever you're coding, whenever you're trying to solve a problem, you can have access to a lot of things. Guess what? In the case of an IDE, you will have access to certain documents called as helper documents. These documents, at the end of the day, while you're in fact using the IDE itself, you'll realize it'll give you a guide about how to use the IDE. It will talk to you about what each of the elements does. And at the end of the day, if you're writing something writing a piece of code in Python, which you think you require more clarity about, it is right there to help you and to tell you more about what is going on with that particular component, right? So when the talk is about components of Spyder, there are a lot of components which will add nothing but efficiency to your arsenal in programming. Now, after components is done, we're going to have to spend some time to understand the various features that are out there for Spyder, right? Now, as I told you, debugging can be done in multiple ways. You can run everything at once and manually sit and debug, or you can set something called as breakpoints, right? As I just told you, you can break your programs into short chunks of code. Just execute those, right? If there's an issue between line number 3 and 10, just make a mark at line number 3, make a mark at line number 10, just execute those. It is possible, especially in a language such as Python, which is an interpreted language. Eventually it'll run it and execute it one by one, right? So all you're trying to do is execute that piece of code, and if there are no dependencies, it will work fine. And the way that you get to work with these debugging styling, right? You can customize how you debug, what you're going to debug, and you can eventually set automatic debugging as well. Now, one important thing you have to understand is that it's not just about debugging. The way you structure your piece of code, let's just say you're solving a data science problem. The starting thing that you would do is basically import all the libraries. The next thing you would do is import the data set, take a look at the data set, pre-process the data set, perform some data analysis, push it to a machine learning algorithm, and so on, correct? You see that each of those can actually be broken down into sub-cell level, right? You don't just need to have a 100-line code that does all of that. You can break it down into 5 lines, 6 lines, which each of those lines has a purpose, right? You can break it down into cells. You can break it down based on functions. You can break it down into blocks of code, which again, maybe you want to reuse later as well, right? If it's something iterative, if it's something recursive, you know that piece of block can be used multiple times. So why not have a feature of how you can do that in a simple way too, right? And one more thing, even though Python is a programming language which does not offer any sort of complicated syntax, or which does not expect you to have semicolons everywhere, in a couple of statements you are going to be required to use a colon, right? For example, the while statement or the if statement. One important thing about Spyder is that if you miss these, it'll not say, hey, error, you missed it, fix it, or I won't execute. No, it'll automatically add one for you, right? Now, again, as I told you, right, when you're writing a lot of code, there's a very good chance you are going to miss it, right? As an experienced programmer myself, I have found myself in a situation where the entire program is correct, but a semicolon but a colon or something like that is missing. Something which is very minor, which will not let the program work, and it will result in an error, right? But if your IDE could help you fix that, even with you or without you even knowing, it works, right? It's not doing anything that would harm the program. It is just doing something to support the program. That works very well. And while you're typing in the code itself, while you're actually writing the code, it can explain to you how things work. Now, this, in my opinion, has to be something which is very important, right? Now, after you've written a piece of code, you can copy it, go to Google, see what's being done in Google, understand it, come back to Spyder, work with it. Isn't that a hassle? Well, not anymore, because as soon as you start writing a piece of code, it can explain what the code is doing in real time. While you type it, it can tell you what that piece of code will do, and you can not just understand what it is about to do, you can also find out things such as where its dependencies lie, how is it affecting the result, what is it contributing to the final solution, and eventually have access to all the functions, the method details, the parameters, and everything at once in a very easy to understand, structured, and convenient manner. So don't you think this is a huge win for you as a programmer? So if you think that, hey, these are so many features, am I gonna use all of those? Well, yes, I'm sure you're gonna use most of these, and in fact there's more features, right? So see, one thing you have to understand about working with a programming language is, again, even though you have the most beautiful interface to work with, if all of your code does not have some sort of coloring, it does not have some sort of highlighting, it becomes very difficult for you to understand what that piece of code can do while you're skimming through, while you're running through. So what Spyder does is it will give you an ability to actually customize the Python syntax highlighting. So it can highlight some things in the colors that you want. Maybe I love having all of my functions in blue color. Maybe you want it in red, right? So that way, as soon as you look at it, you know what that is, even without having to spend a second of your thought figuring it out, right? So that kind of a convenience is also there. Eventually, you will have the ability. It doesn't have to say I have a 100 line piece of code, I have to execute all 100. Not really. If you have a 100 line program, if you want to just execute 10, do it. If you want to execute 1, do it, right? So that ability is super important. And we spoke about the variable explorer as well, right? So think about it. After you're working with a variable, when you're done using it and you know you'll not use it again, automatic memory allocation and deallocation is still there, but IDE will give you that extra headroom to make sure that, it cleans up all the variables, all the space that the variable is used. Of course, all these sample programs, the tiny programs you might write might take minute amount of spaces, but when you're writing a huge program, it can bog down your computer, right? It might be using a lot of space, even though you have nothing to do with that variable anymore. So that automatic cleanup, the processing, it's called garbage collection, right? So all of those works fine. And if you worked with Python previously, IPython has some magic commands. When we say magic commands, it's basically commands which will help you out to a very good extent, right? So having access to these commands in an IDE is fantastic, and Spyder does it really well. Right, guys, so with this, we have to understand how we can go on to install Spyder. Now, installing Spyder, as you might think, right, it can, I've heard people saying, hey, installing an IDE is such a hassle, I would rather write it in a code, I would rather write it in a text editor and do everything else. Well, that is more complicated, I'll tell you, because installing Spyder is not really difficult. I'm sure you might have heard of this package called as Anaconda. Anaconda is again a super popular package for Python, which at the end of the day that you can use. And as soon as you start setting up and installing Anaconda, and as soon as you start working with it, it will give you everything that you require to work with Python, right? So it's a very simple step to install Spyder. All you have to do is install the latest version of Anaconda. There's a very nice step-by-step guided installation procedure, and as soon as that is done, you just verify if it installed fine, and you can begin with that, right? So in fact, let's go on to install let's go on to install the Spyder IDE right now, and I'm going to be doing it through Anaconda. So what I'm going to do is I'm going to type Anaconda. Let me just do this, right? So Anaconda Python. Now, the first link that I get, the individual edition, right? Of course, there's many paid versions of Anaconda as well. Having a distribution and especially having, let's just say, a free version is going to help you guys a lot. You have the individual edition for that. Just click on download. It's somewhere around 400 or 500 MB. I think it's 477 MB, right? So while that is downloading, take a look at it, right? Basically, Anaconda in a commercial environment, if you're using it for a commercial environment, you have to buy it. But if you're working on it for yourself, if you're working on it as an individual, you definitely can use the free version. There's 25 million users who use it, and it's not just Python that Anaconda supports, it also supports programming languages such as R, which again is super popular in the world of data science and data analysis and all of that, right? You can find out a lot of things about how you can work with Anaconda, but again, it's very simple, it's very straightforward. You can see that there's a lot of access for you to work with, and here as well, look at this, right? Spyder, this is what we are after, and it's not like we're just trying to install Spyder, it's giving us everything else as well, right? So it downloaded. Let me quickly head to my desktop right now, and let's get started with it, right? So as you can see here, it says welcome to Anaconda 3. All you have to do is hit on next, hit I agree, and of course here it is basically asking you who do you want to install it on. If it is just you, or if you require it to be for everyone else. If it's for all users, it's going to ask you for a quick admin access. As soon as that is done, it's very simple. Hit next. You don't have to change anything at this moment. If you want to add Anaconda to your path variable later, it's also possible. So it's a very simple process of hitting next, and literally waiting for it to install. Now guys, I know that you guys will be super excited to work with Anaconda, but you have to understand the setup is going to take at least 5 minutes, right? It definitely, if you're installing Anaconda for the first time ever, it's going to take a lot of time, right? 5 to 10 minutes is minimum. So just wait it out, even though it seems like it's frozen, even though it might seem like it's not really doing anything. It will work. You just have to give it 5 minutes, right? And as you can see on the screen itself, the advantage about Anaconda is that it will work really well regardless of the operating system you guys are using it on. Some of you might be using Windows, some of you might be using Mac OS, some of you might be using Linux as well, right? So Anaconda is a distribution that works in all these works on all of these operating systems. So whatever it is you're using, the installation might vary a little for Mac OS. Of course, it's slightly different for Windows and Linux, but yes, you have the ability to use it. You can eventually start working with Spyder in the most easiest manner, right? So now guys, it's going to take about 5 minutes. Let's wait it out. As soon as the installation is done, I'll show you how you can verify the installation and how we can get started with Spyder. Alright guys, as you can take a look at it, this took a solid 5 to 10 minutes to install, and it's pretty simple, right? As I told you, even though it might feel like it's actually hung, it wouldn't have. So make sure that you guys are taking care, and eventually you can all these tutorials and all of that, it's very simple. I'm just gonna untick them, hit finish. Right now let's actually head to the desktop. Right, now we are at the desktop, right? So now to check if Spyder is installed or not, it is very simple, ladies and gentlemen. Literally just type Spyder. In fact, just type Anaconda first. Since we installed Anaconda, let's just make sure that all the dependencies that Anaconda brings with it is installed fine, right? So as soon as you click on Anaconda, you can see it's going to start running. It's going to initialize everything that it's required. It's going to open the Anaconda, the Explorer. It's going to give you like a complete toolkit that you can there's a lot of things that you can do with it, but for our case, we're just looking forward for Spyder, right? So again, let's give it a second, and it does all of this for the first time. The second time onwards, eventually it will load a lot faster, right? Again, that just took 20 seconds, and you can see, right, we are at the navigator here, and the navigator will give you access to so many different things. Now, what are we after? We are after Spyder here, right? You can see Spyder and it's already installed. Now, if something is not installed, you will see it as an install button. For example, PyCharm is not installed. Even though they'll give you the access to it with respect to Anaconda Navigator, it's not installed by default. So it says install here. But you can see that with respect to Spyder, let me just scroll it a little bit up. Yeah. So with respect to Spyder, you can see it's already installed. It just says launch. So all I have to do is hit launch, or another easy way for you guys to launch Spyder is just click on start button, click on Spyder, right? Just click on Spyder and you're done. Either way, it is going to open. So let's just give it a second. So guys, as you can see, Spyder is opening, right? So when you see this loading screen, it means that Spyder is initializing. Again, there are a lot of things that you are going to have to do for the first time. Again, you can see that there is an option which says, hey, there's a Spyder new version available, in fact. So there's a part where you're going to get an entire tour of how the user interface is. Now I'm just going to hit dismiss. You guys can definitely go on to take the tour there. And as you can see, guys, it's a very simple environment. On the right side bottom, you guys have the console. On the top left, you guys have the Python code here. Right now, to execute a piece of code, it's very simple. All you have to do is type in the piece of code, and as I told you, right, while you type, it's going to give you all of these options that you can use for the function. Right, it's very simple. In fact, let me just zoom in on the code. Hang on. Yeah, so this should be visible, right? So while typing it itself, you're going to see that it's giving you so many options. Now I'm just going to type my name is Anirudh Rao. And what do you do to run? All you have to do is, it's pretty simple. Run a file and it'll ask you where you want to execute it, right? Since this is a temporary Python code that we are trying to execute, you want to execute it in the current console. You want to have a separate console, external command. So look at this. It'll give you like, a lot of options for you to actually go on to run. Now, as you can see, I just hit run, and eventually at the bottom right, you can see the console here, right? And it just printed out something that says my name is Anirudh Rao. Now, I can understand that it can be a little small for you guys to take a look at, but yes, it works pretty well, right? Now, if I just say a equal to 10 without any context, and if I actually go on to print, on the top right, you have something called as the variable explorer that I told you about, right? When I say a equal to 10, it automatically understands the name of it as 8, understands the type is integer, it also understands the size is 1, right? So eventually you'll find out the value that is put into it. Now, if I just type b equal to, let's just say Anirudh again. Let me just execute this, and now you will see that b is not an integer, it's a string, the size of the string, and eventually what the string consists. So if you guys required some clarity about what the variable explorer does, having this kind of flexibility is absolutely fantastic, right? So guys, running through the menu, it is pretty simple. The file tab is going to be very straightforward. New file, open a file, any recent files that you might have to open, or if you've written a piece of code, you can just quickly hit Ctrl Z as usual and it will clear it out. If you have to work with different files, if you have to close one particular project, right? Now temp.py, as you can see, is one file. If I close this, I still have a lot of files that I can work with, right? So you can work around with all of that. In the edit menu, you can work about how you can go on to comment a piece of code, or how you can go on to uncomment a piece of code. For example, if I type print demo here, and let me zoom in a little so you guys can see this. I'm going to select it, and I can actually hit Control 1. And Control 1 is basically the shortcut for demo, for basically commenting it, right? You can see the shortcut right here. When I go to edit, it says comment and uncomment. Now, if you can add a block comment, remove a block comment. Block comment is basically something like multi-line comments, right? Let me hit Control 1 again, and it removed that. So edit is pretty straightforward. You can go on to work with toggle uppercase, lowercase, indentation, shift tab will unindent it, and all of that. In the search, you can find out all the files you're working with. In the source, you can just say, hey, do you want to show blank spaces? Do you want to show the docstring warnings? What do you want to show? Where's your cursor at, right? So literally everything that you really have to know about it. You can find out code analysis. Code analysis will basically export a text file for you. Running it is very simple. You can create individual cells that you guys have to work with. Basically, when you're starting out, you're going to be writing code in one part, and eventually like a Jupyter Notebook, you can break things down into cells. You can run one particular cells and just move to the next one as well. Or if you want to run everything, you can do it. If I just say that there's 10 lines of code and if I just have to execute this one line, I'm going to select that and say, hey, run selected or run the current line of code. A shortcut is F9 that you would popularly use, but yes, right? So you can set the configuration per file as well. You remember this was shown the first time, and you can just select it for every file, for every type of file that you execute and all of that. And debug menu is where you would just select it. Setting a breakpoint and clearing a breakpoint is where you would, start working with that particular point. To stop the execution, stop the debugging basically, or step. Whenever you say step, all you're trying to do is now, let's just say, let me copy the same line of code probably 10 times, right? So I'm just going to copy it a couple of times. Now, if I have to say, hey, I just want to execute all of these, I can do it. If I just want to execute this one, I can still do it. Now, while debugging, if I have a breakpoint from here to here, and if I say step, or if I just move the mouse next to it, you see that red color highlighting, it means that I've selected a breakpoint there, a track point there, right? So when I say step, it basically executes this, waits for me, and as soon as I click enter, it executes the next one, right? Similarly, for every single breakpoint, you can select all of these, and it is very convenient. Sometimes you can, you can be working with something, you might have a kernel error, so you can remove like all the variables, right? So when I hit remove all the variables, you can see that everything is removed. I told you it can automatically do this as well. With respect to projects, again, you can have any sort of modularity that you guys require, be it in terms of how you're going to create a new project, open an existing one, and all of that, right? So tools and preferences is where you guys might be spending a decent amount of time at the start, because it gives you a lot of options, right? From how you can work with the interface. What is it that you want to see? What is it that you don't want to see? Right from appearance, as in, look at this. In the right, it says interface theme, light theme, dark theme, icon theme. You can change all of that. Syntax highlighting also. Here you can see that the name of the class is in blue color, or all the reserved keywords are in orange. Maybe you just want to change it to something else. You can change all of that here. As I told you, right, a lot of customization options based on each one of us has our own preference. So whatever your preference is, just run through the highlighting theme, check it out. You can set your own shortcuts. You can use the same interpreter as that's installed with Spyder, or if you want to use a separate interpreter that maybe a different Python version, you can use that as well. All of these options is basically giving you a simple way of how you can navigate through, have this kind of a flexibility. Now, if you were just writing Python code, this is all that you would see, and you would in fact see one console, and you just have to keep writing on the console itself, or you have to execute a file, and eventually it will just reduce all of your options down to an absolute bare minimum. But with a console such as this, you realize that, right? All I had to do was install Anaconda, and as soon as I installed Anaconda, I just opened up Spyder, and I'm ready to start writing any piece of code. I'm ready to get more help if it's required as well. You can just click on any object, press Ctrl I, and it will give you a lot of details on it. Even if you just hover your mouse over it, right? If you just put your mouse over it while typing it, it's going to give you a lot of details. You can take a look at the plots, the various files that you're going to work with. So ladies and gentlemen, it's actually a very simple, it's actually a very straightforward console to work with, an IDE to work with. And my suggestion to you guys is, whenever you guys are beginning, or whenever you guys are working with Spyder IDE, and whenever you guys are looking forward to configuring it, right? Now I cannot say, hey, do this, because your configuration, your preferences might be very different from mine. I just quickly walked you through all of the things that you can actually do, and with this, I hope it should be very simple, and at the end of the day, very straightforward to work with it. But you have to know why it is that you have to prefer Spyder, as I've already discussed, and you have to know the advantages of using an IDE, not just with Python, any programming language out there, but this kind of a convenience, especially for a beginner, is very, very important, right? You don't have to mess around with something, deal with a lot of errors, or have trouble installing. Just go to Anaconda's site, download Anaconda, install it, 3 clicks of your mouse button. You are done with everything you need to actually start writing the code, right? With that, I don't think it can get any more convenient, right?
So we'll start by installing R, and you can install R from this particular site over here. So we've got cran.rproject.org. So let me just click on this link over here. Let me just wait till this loads up. Right. So we've got different versions of R. So if you're using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. And if you're using a Windows system, then you can download R for Windows. And since I'm using a Windows system, I'll be downloading R for Windows. So I'll click on this link. All right. So again, we have this option to install R for the first time. I'll click on this. And this is the latest version of R 3.6.1 for Windows. I'll click on download and the download would start. Now, after installing R, we would also need an IDE. So IDE basically gives you certain features so that implementing code becomes much easier. So if you have worked with Java, then you would know that there is an IDE for Java called as Eclipse. So analogous to that, we also have something known as RStudio when it comes to R. So RStudio is the IDE which makes coding with R extremely easy. And to download RStudio, you can go to this particular site over here, rstudio.com. So I'll click on this link. Alright, so this is the site, and over here we'll be basically downloading the free version of it. So I'll click on download, and we've got different versions over here again. So if you're using a Ubuntu system, you can download it for Ubuntu. Then we've got Debian, Fedora, and so on. And since I'm using a Windows system, so I'll download the 64-bit version for the Windows system. Right. So now the download for R and RStudio is complete. Now let's turn to the programming part. So we'll start by understanding what exactly are variables in R. So simply put, variables are just temporary storage spaces. So let's take this example to understand variables in a better way. So you see this shopping bag over here. Now consider that you can only store one item in the shopping bag at one particular time, right? So what you do is you have the shopping bag with you. You go ahead and buy a phone, and then you take this phone and place this inside the shopping bag. So over here, this is your variable, and you are storing this particular data item, which is a phone, inside the shopping bag. So after some time, you decide that you don't need a phone and you actually need a pen. So you take this phone out and you put this pen inside this shopping bag over here. And again, after a while, you decide that you don't actually need a pen and you need a makeup kit. So again, you take out this pen from the shopping bag and then you place this makeup kit inside the shopping bag. So over here, this shopping bag is basically acting as a variable. So first it stores a mobile phone, and then it stores a pen, and then it stores a makeup kit. So this is what exactly is a variable. It stores temporary values inside it. Now going ahead, we'll work with these variables in RStudio. So this is RStudio, guys, and we've got all of these panes over here. So this is the script window where you can write all of your script. This is the console window where you can execute your code. And then we've got the environment window over here, which basically shows you the different variables you have. And then we've got this packages and plot window. So this basically shows you the different packages which are already installed, and you can have a glance at all of the plots in this plots window. Right. So let's go ahead and see an example of variables. So I'll go ahead and create a variable with the name var1, and inside this I will store the value, let's say phone. Now I'll print this out, var1, right? So the value is phone. Now what I'll do is inside var1 again, I will store the value pen. Now let me print out var1 over here. So initially the value stored inside var1 was phone, and then I change this value to pen, and when I print it out, the value is pen. So this is how a variable works. So it basically stores temporary values, and you can change that value whenever you want. So again, I will go ahead and change this value. So instead of pen, I will store, let's say, makeup inside this. Now I'll print this again, right? So now the value of var1 is makeup. So this is how variables work in R. Now every variable is basically associated with a data type, and every data can be of different types. So data can be of numeric. So if you got numbers such as 3.14, 75 and 500, this is basically numeric data type. And then we also have character data types over here. So if you have names such as Sam and Bob, or if you say sentences like I love pizza or my name is Sam, so this is basically character data type. And then we've got the logical data type where you basically have two values. First value is true and then the second value is false. And then finally we've got the complex data type. And in complex data type, you have two parts. First is the real part, and then you have the imaginary part. So over here, we've got numbers such as 7 plus 5i and minus 3 minus 9i. So in 7 plus 5i, 7 represents the real part and 5i represents the imaginary part. So these are the different data types which can be present in R. Now again, let's go back to RStudio and work with some data types. So I'll clear this out. Now again, I'll take a variable with the name var1. I'll put in equal to, and let me store a numeric value inside this. So I'll store, let's say 12.34, and then let me print this out, var1. Now let me check the class of it. So class of var1. So inside the class function, I am passing on this variable1 object, and you see that the class of this variable is basically numeric. Now in this var1, what I'll do is I will basically store a character value. So inside this, now I'll store, let's say Sam, and then I'll print out var1 over here. Now let me check the class of it. So class of var1. Right, so initially when we had given a numerical type to this var1, the class was numeric. After some time, when we went ahead and stored the value Sam inside var1, the class changed to character. So the class of the variable basically depends on the type of the data which you store inside this variable. So if you given a numeric type data inside the variable, the class of the variable would be numeric. If you given a character type data inside the variable, the class of the variable would be character. Similarly, if you given a logical type data inside the variable, then the class of the variable would be logical. So that is what we're going to do now. So I'll type var1 over here, and inside this, let me give in a logical value. So I'll type in true over here. And when it comes to logical values, in R you have to keep in mind that all of the letters have to be capital. So TRUE, all of the letters have to be capital. Now let me check the class. So class of var1. Right, so we see that this is logical now. Now finally I'll store a complex value inside this. So var1 equals to, I'll say 13 plus 6i. Now let me check the class of it. So class of var1. So see that this is complex. So these are different data types which can be present in R. Now going ahead, we'll work with operators in R. So these are the different types of operators in R. We've got assignment operators, arithmetic operators, relational operators, and logical operators. So we'll be starting with assignment operators. So with the help of assignment operators, we can basically assign a value to a particular variable or a particular function, right? So this is what assignment operators are used for. So let's say I have a variable with the name A and I want to assign a value to this. Now there are three varieties of assignment operators. First is the equal to operator. So I'll just give in the equal to value and I'll store the value 8 inside this. So what I'm basically doing is I am storing the value 8 inside this variable A. Now let me print this out, right? So we see that we have assigned the value 8 to A. Now I have another variable with the name B and I will use the second type of assignment operator. So this time I am using a less than symbol and after that I'm giving a hyphen and then I'll store another value inside this. So let's say I given the value hello. Now let me print this out. Right. So now I have assigned the value hello to the variable B with this assignment operator. And then finally we have the third assignment operator where we actually given the value first. So I'll given the value which is true. And then I given this assignment operator. So over here I given the hyphen first and then I given the greater than symbol. And then I'll given the name of the variable where I want to store. So I want to store this in, let's say, final. Alright, now I'll print out final over here. So we have successfully stored the value true inside final. So I'll just print out all of these three assignment operators. First is the equal to operator. And then we've got this operator over here where we given less than symbol and then we given hyphen. And then we've got the third assignment operator where we given hyphen and then we given the greater than symbol over here. So after the assignment operators, we've got the arithmetic operators. And arithmetic operators are used to perform simple mathematical functions such as addition, subtraction, multiplication, and division. So we'll see an example of each of these. Now for doing that, I'll basically create two variables over here. In the first variable, which is num1, I'll store the value 10. And then I'll go ahead and create the second variable with the name num2. And inside this, I will store 20. So now I've got my variables over here. Going ahead, I'll perform some mathematical operations upon these two variables. So let me just print out these two variables in the console first. Right. So I have successfully created num1 and num2. Now I'll type in num1 plus num2. I'll copy this and I'll paste it over here. And we get the result 30 because when you add 10 and 20, you get the result 30. Now similarly, I'll perform the next operation over here, which would be num1 minus num2. Because when you perform 10 minus 20, you get a value of minus 10. Now I'll perform the multiplication operation. So it would be num1 into num2. And when you perform 10 into 20, you get a value of 200. And then finally, we'll perform the division operation, which would be num1 divided by num2, and you get a value of 0.5 because 10 divided by 20 is 1 by 2. So these are some of the basic arithmetic operations which you can perform. So next up, we have the relational operators. In relational operators, we've got these symbols over here. So you've got greater than symbol, you've got less than symbol, you've got double equal to, and you've got not equal to over here. Now again for this, let me just use the same numbers of num1 and num2. So I'll type in num1 equals 10 and then I'll type in num2 equals 20. I'll copy these two variables and I'll paste them over here. Now let me start off with the greater than symbol. So I'll type in num1 and then I'll put in the greater than symbol and then I'll give in the second variable which is num2. So I'm basically checking over here if num1 is greater than num2. So we get a false value. Now we get a false value because num1 is actually less than num2, or in other words, 10 is actually less than 20. Going ahead, we'll use the second relational operator, which is less than. So now we are checking if num1 is less than num2. And we get a true value because 10 is actually less than 20. Going ahead, we have the double equal to operator. So over here, I'll put in double equal to. So with the help of double equal to operator, we are checking if the values stored in both of the variables are equal or not. Again, I'll hit enter. So we get a false value because 10 is obviously not equal to 20. And then finally, we have the not equal to operator. So the not equal to operator is given like this. You give in the exclamation symbol and then you give in the equal to operator. And then we get a true value because 10 is obviously not equal to 20. So these are some of the relational operators. Going ahead, we'll work with logical operators. And to work with logical operators, we'll create two more variables. So I'll create a variable with the name log1 and I'll store, let's say, true in this. And then I'll create another variable with the name log2 and I'll store false in this. Alright, so I've got my two variables ready. Let me execute them first. So I've got log1 and log2 ready. And the two logical operators which we have are basically AND and OR operators. So let's understand a bit about the AND operator and the OR operator. So the AND operator basically gives a true value if both of the operands are actually true. So let's understand this over here. So over here, I'll type in log1 and log1. So we know that the value stored in log1 is true. So when you say true and true, you get a true value. Now let me type in log1 and log2. We get a false value because true and false become false. Similarly, let me type in log2 and log1. Again, we get a false value because both of them have to be true. But over here, log2 is false. Now let me type in log2 and log2. Again, we get a false value because both of the operands have a false value in them. So when it comes to the AND operator, we have a true value only when both of the operands are equal to true. So OR operator gives a true value when any of the operands has a true value, and it gives a false only when both of the operands have a false value. So again, let's understand this with an example. So log1, I'll give in the OR operator and then I'll type in log1. So true or true. So we get a true value obviously. And then I'll type in log1 or log2, which basically comes to true or false, which is true again. Now I'll type in log2 or log1, again get a true value. And finally, let me type log2 or log2. Now since log2 is false, so we are basically trying to check if false or false. And since both of the operands are false, we get a false value over here. So these are the logical operators. Now let's go ahead and work with some inbuilt functions. So we'll look at all of these different inbuilt functions over here. And we'll be working with all of those inbuilt functions on top of the iris dataset. And as I've already told you, to have a glance at the dataset, we'll be using the view function. So I'll type view of iris. So this iris dataset basically comprises of 5 columns in total, which are sepal length, sepal width, petal width, and species. Now this dataset basically comprises of the 3 species of the iris flower, which are setosa, versicolor, and virginica. And we've got the corresponding sepal length, sepal width, petal length, and petal width corresponding to those three species. Alright, now let's work with those inbuilt functions. So the first inbuilt function was the structure function. So all we have to do is type in str, and inside this I will pass in the data frame, which is iris. And this gives you the entire structure of the data frame. So over here, this tells you that there are 150 observations of 5 variables. Or in other words, there are 150 rows in this data frame and 5 columns in this data frame. And then you also have a bit of description about each column. So you see that sepal length is a numerical column, and these are some of the first few values in this column. And then we've got sepal width, which is also a numerical column. Then we have petal length and petal width, which are also numerical columns. And then finally, we have the species column, which is basically a factor variable with 3 levels. So this is why the structure function is used. So after structure, we've got the head function. So with the help of the head function, we can have a glance at the first 6 records of this data frame. So inside this, I will pass in the name of the data frame, which is iris. So we've got the first 6 records of this data frame over here. Similarly, if you want to have a glance at the first 10 records, then all you have to do is use in n over here and then give in the value 10. And then you can have a glance at the first 10 records of this entire data frame. So similar to the head function, we've also got the tail function, with which you can have a glance at the last 6 records of this data frame. So first, all you have to do is pass in the name of the data frame inside this. And these are the last 6 records which are present in this iris data frame. So starting from row number 145 going on till row number 150. And these are the last 6 records present in this data frame. Similarly, if I want to have a glance at the last 10 records of this data frame, I'll use n equals and then I'll pass in 10 inside this. And these are the last 10 records which are present in this data frame. And then we have the table function. So table function is used to identify the frequency of the categorical columns, or to understand the count of different levels which are present in a categorical column. So I'll type in table, and the only categorical column which is present in this iris data frame is the species column. So I'll select the species column, iris $species, and we see that there are 50 entries of Setosa, 50 entries of versicolor, and 50 entries of virginica. So this is how table function can be used to get the frequency of each of the different levels of a categorical column. Next, we've got some arithmetic functions. So we've got min, max, mean, and range. So if you want to find out the minimum value in a particular column or a particular vector, then we can use the min function. So inside the min function, what I'm doing is I'll pass in this sepal length column. So I want to find out the minimum value of sepal length. Iris $sepal length. So we see that the minimum value of sepal length is 4.3. And then I'd want to find out the maximum value of sepal width. So to find out the maximum value, I'll use the max function. And inside this, I'll pass in iris $sepal width. And the maximum value of sepal width comes out to be 4.4. And now I'd want to have a glance at the mean of petal length column, or the average petal length of the different records which are present in this data frame. So I'll type in mean, iris $petal length, and the mean petal length value comes out to be 3.758. And then we've got the range function, which basically gives you the minimum value and the maximum value, which is basically the range. So I'd want to find out the range of this petal width column. So I'll type in range, and inside this, I'll type iris $petal width. And we see that the minimum value of petal width is 0.1 and the maximum value of petal width is 2.5. So these were some of the inbuilt functions in R.
In today's video, we looked at installation of IDE, its feature, and walked through with simple code execution on various IDE like Jupyter Notebook, Google Colab, Spyder, and RStudio with the help of Python Programming Language.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.